All right, welcome everyone to our next edition, the current edition of the eVTOL Writers Group. Today we have a great interview for you, Mr. Chip Downing from RTI, Real-Time Innovations. He's going to be talking a little bit about using industry standards. So I first want to take care of some housekeeping items. First, you can submit your questions to our speaker by using the chat/questions box on your GoToWebinar dashboard, and our moderator for today will process those questions and ask them towards the end. So we're looking forward to a great presentation today, and your input will be key to that. So with that, I will go ahead and introduce our moderator for today, Mr. Charles Alcock. He is the senior editor for AIN International. And with that, Charles, go ahead and take it away. Thank you.
Thank you, Jim, and hello to everybody, wherever you may be, whatever time it is. It's good to be here with you. Now, of course, autonomous flight is very much a holy grail item for much of the so-called advanced air mobility sector. I'm the first to confess that I still don't fully understand what it's going to take to safely deliver on this promise. So it's always good to have access to expert advice, and that's the sort of advice we've got today. We're joined by a company called Real-Time Innovations, and they're engaged in helping to establish the basis for introducing autonomous platforms, and at least as importantly, the standards that will apply to these. So I'm glad to introduce Chip Downing. He is the company's Senior Market Development Director of Aerospace and Defense, overseeing work on its RTI Connect product. He's had a long career with several companies developing avionics, including Wind River, and he's also very much engaged in the process of setting standards. For example, he's chair of the Future Airborne Capability Environment outreach team, and I'm hoping we're going to learn more about that. So, Chip, please help us to understand why these standards matter so much and the work that you and your colleagues are doing. We'll let you introduce that and then try and get to some questions if we may.
Okay, appreciate it. And thanks everybody for joining today. Hopefully I'll keep you entertained for at least a half hour, maybe let you find out a few new things that may be impacting the eVTOL community. You do next slide, it'd be great. Now, if you took a look at the abstract, I'm going to talk about three standards today: the DL178C avionics software standard, also the FACE military avionics standard, then the DDS connectivity standard, and then I'm going to try to tie all three of these together, which doesn't make sense right now if you don't know about these standards, and it's somewhat of a challenge, but I think it'll be interesting once I put all these three standards together. So next slide, please. So just a quick slide on RTI. We're the leader in what's called software connectivity frameworks for autonomous systems. We've got headquarters in Silicon Valley with worldwide offices. We have over 1,500 commercial design wins. We have over 1,200 in aerospace and defense. We are this leader in what's called a data distribution service standard, the DDS standard. And because of autonomy, we're having growth of about 25% per year. Next slide, please. Now, you'll see the type of traction we're getting here. And it's interesting when you think about going from manned vertical lift platforms to autonomous vertical lift platforms, you need to have this one thing called data. You need to have a lot of sensor systems, a lot of capabilities to integrate that data and process that data in real time. And that's what our product does. So we've got very, very strong traction. This is last year's data, we probably have over 300 design wins now. That goes from passenger vehicles to underwater rovers, airborne platforms like Vahana, autonomous trucks, hyperloops and things of that nature. Lots of in defense systems, and over 75 research programs. So it's very, very strong traction in this space. And most people are now starting out with some type of connectivity platform when they do the design. So next slide, please. We're also involved with the Indy Autonomous Challenge, and that's sort of a really cool idea that they've come up with, where essentially you're going to get over 30 teams from different universities around the world competing. You're going to drive an autonomous race car. This is the same type of race car that you actually have manned for Indianapolis 500. You're going to drive it around the Indianapolis racetrack at speeds close to 200 miles an hour. And it's interesting that it's now being done virtually using the ANSYS tools, where you can actually have a virtual race, essentially a digital type twin race, and then they'll do a final race this year in October. So it's a really nice way to use both the RTI technology and technologies for digital twins like ANSYS. Next slide, please. I think one of the most interesting projects I've been involved with so far is the Veron Vehicle Skyscraper project. This is really based by Felipe Veron out of Colombia. He's actually taken a look at the whole picture of how do you actually put autonomous urban air mobility systems into a country. He doesn't have quite the, I'll say, the baggage we have in the United States. You have a relatively small country, but it's very complex, very densely populated in large cities. And he's taking a look at the entire picture between safety, security, regulations, all the political issues, technology issues, and also finance and educational operational. He's just taking a look at that whole scheme of things. And if you ever need to take a look at some of these different challenges, he actually has what's called think tanks, where you actually dive into these different challenges and have experts in the industry talk about it. I'll talk about this more later. Next slide, please. So let's talk about DO-178C. The next slide, please. DO-178C is a avionics safety standard for software. There's also a companion standard called DO-254 for avionics hardware. This is jointly developed by RTCA and EuroCAE. It's a global force of individuals that have contributed to this standard. It's well proven. It started out as DO-178 30 years ago. It's now in its essentially third revision. It actually takes a look at all aspects of doing certification for an aircraft in flight. Next slide, please. So there's different standards for airborne systems, lots of them. Some companies like AirRank have quite a few, but there's DO-254, as I mentioned, DO-170C for software, and there's system development, ARP 4754A, safety assessment, certification specifications. So there's lots of different requirements, and there's standards to actually help you through this entire process. The good news is, especially with DO-178, it's a well-known standard. It's known globally, and there's literally thousands, tens of thousands of people that actually deliver software for this standard. Typically, and it's also done, it's reviewed by what's called an FAA designated engineering representative, DER, which are outside the FAA, but wear an FAA hat to review the data that you put together. Next slide, please. A little bit of a lag here, but so there's different levels. So it's not every airplane has the same safety challenges. Typically, for large passenger aircraft, you're going to have the highest design assurance levels, or DALs, and that's called DAL A under DO-178C. So most of your flight systems and primary control systems on a large aircraft are going to be DAL A. This goes down with smaller aircraft, biz jets, and smaller personal aircraft from level DAL B to DAL C, and then there's DAL D, essentially has a minor impact on overall safety of the platform. So, but it's one thing where you don't have to do the level A for everything. You can actually mix these different DALs on different types of systems on an aircraft. Next slide, please. There's interesting also that because of the complexity of doing this, you have to, there's been companies that actually create tools that help you guide to do this, actually test and verify and actually generate code that does not have to be white box tested. So it's very interesting that these tools exist. They before DO-170C, there's an FAA order 8110.49 chapter 9 that actually talked about two different types of tool verifications. There's design tools, which are really modeling tools that generate code that does not have to be tested at the white box level. There's also verification tools. So essentially, you prove that this tool is not changing the behavior of your code, and it's really for doing structural coverage, essentially making sure you get every line of code tested whenever you go off and do this this process. And it has different qualification levels matching to the safety requirements of the platform. Next slide, please. There are quite a few tools that are out there, especially for embedded platforms, that actually do these DO 330 certification tools. They go from AdaCore and ANSYS for design tools to Crusadus for doing graphics cockpits, MathWorks, once again, for control laws, design tools, and then there's real-time operating systems and other types of tooling out there. Next slide, please. So let's talk about FACE. So FACE is the Future Airborne Capability Environment. Go ahead and do the next slide. FACE was started back in 2010 by government and industry and academia. It's really to try to fix this problem of how do you make software portable across platforms? How do you remove the vendor lock that you tend to have, I'll say really on legacy manned platforms? Now, traditionally, you think about a F-14 or F-18, the F-35, they had a single purpose or had a fairly bounded purpose. Platforms today, especially as you bring in unmanned and autonomous unmanned, you want to be able to share those capabilities across these different platforms because a lot of them are exactly the same. So this way here, you can actually move mission systems and possibly flight control systems onto new platforms very easily. There's the three parts. Essentially, there's a business process to actually make this go faster, so you don't have this very long procurement process of bringing in new software. You also have got technical practices, and there's a written technical standard that's based upon APIs I'll talk about in a couple of more slides here. And then just the standard itself that for both business and technical that allows you to promote and use this software standard in live aircraft. Next slide, please. The nice thing about FACE is they did not invent another standard when one already existed. So it's really a standard of standards. So it started out over 60 standards. They've actually compressed that down a bit, but most of these standards are already well known in the avionics industry. We have ARINC 653 and 664. You've got the OpenGL, POSIX. There's also like a design tool, a design model, a data model called UDDL that we did invent. XML, Java, things of that nature. So it's nice that they said, if a standard actually works, let's just use that. That'll be part of this FACE standard. Next slide, please. Now, what they did, they created a layered architecture. At the top point, it's really what's called portable component segments, the PCS. And that's this is the highest level what you want as far as portability goes. You want to be able to take applications very quickly and move those onto different platforms with minimum integration challenges and rework, and certainly lower risk. Below that, there's a FACE Transport Services segment. This prepares all the data and information for all the applications. This is what the applications write to. So this is the Transport Services segment, as they call in that to get and receive data from the platform. The lower level below that is called the platform specific services segment. This is the type of information and systems that are on a specific aircraft platform. So you might have different capabilities for different types of aircraft. This is where that information feeds into. And then there's a FACE IO services segment. That's really where the device drivers exist for all of the hardware devices that are on a board that's inside an avionics platform. And then there's the operating system segment that allows you to run the board with a single core, multi-core systems reliably using either ARINC 653, it's a time and space partitioning, or just POSIX. Next slide, please. One of the interesting things FACE did, they also have a conformance program. So essentially, you can create a FACE software, but then you can put it through a conformance process. And this is really somewhat unique in the industry where they actually have a very public way of doing this. You essentially have there's three entities. There's the verification authority that actually takes a look at the output of the test that the Open Group provides you. There's also what's called a certification authority that essentially certifies that the the data is correct and the verification authority did the right thing. And then there's a library administrator that actually stores information about the software, but it's not the library, it's not the software itself. You have to go elsewhere to actually download that software. So it's a nice certification process, and many companies have now done this. Next slide, please. You can see here, there's actually, there's per yesterday, I think there's now 24 certified phase conformant products from different suppliers in the phase registry today. There's also phase conformant products that are not inside the registry for mainly for military platforms. So you're not going to be able to, you don't really want to advertise everything that's on a particular aircraft in a military situation. So there's other platforms that also have phase conformance there. Next slide, please. So next we're going to talk about data distribution standards. This will be the last standard. So essentially data distribution standard was a standard, the publish subscribe standard. If you go to the next slide, please, it'd be great. It's publish subscribe standard that has three parts to it. One, there's a DDS API that programmers write to, and those programmers can use any type of language. It can be Ada, it can be C, C++, Python, whatever. And this is a common API that people just essentially either publish or subscribe to data. That's all it does. Beneath that, there's going to be the RTPS protocol. This is essentially a wire protocol that makes sure everybody's speaking the same language on the wire. So it makes it very easy to have interoperability. So when you talk about having interoperable systems that need to share data, this is where the foundation of that interoperability is. And a really interesting thing they've done with DDS, they have this plug-in security. So they have different types of security capabilities that go layer on top of the DDS implementation. You don't have to rewrite your system or repartition your system or do a fundamental architecture change to actually add security. You can just add security at the data element level, not the pipe level or any other types. You can look at individual pieces of data and encrypt them and authenticate them separately. So you can now have very lightweight as far as performance goes, security with very heavyweight impact. Next slide, please. So I talked about publish, subscribe. Go ahead and toggle through here. Essentially, we have an abstraction called a data bus, but this is just data in motion. And you have publishers publishing data and subscribers subscribing to data. And there's a discovery process where the subscribers say, do you have data of this type? Someone will respond back, yes. And then you build up a contract and say, I only need this 10 times a second. So please send this to me as 10 times a second with this type of reliability. It doesn't publish, and if you're a publisher, let's just say you can do 100 times a second, but nobody's subscribing to that level, you don't put that information on the wire. So it makes it very, very efficient as far as data on the wire. So you're not dumping all the sensor data on a wire only to consume maybe 10 or 5% of that data. It also, it takes out of the picture all of this networking capabilities. When you're talking about IP addressing and worrying about quality of service and worrying about reliability and authentication, all of that is done by DDS. So everybody writes the same type of application logic, and it just goes right on top of a network stack. That network stack can be UDP, shared memory, whatever. It's network independent of that. But the nice thing is everybody now is reading and writing data. You're not having custom parts that are in that orange on the right side. If you hit the one more advance there, it'd be great. We also don't expect everybody to have the same type of data on the same type of data infrastructure. So we actually have ways to actually connect up different types of data, whether you actually are using DDS or you're not. So you can actually bring in data or export data to legacy systems typically that don't have a DDS framework. Next slide. I think you have to hit 2. There you go. One more. There we go. So this is an example of some of the security capabilities that you can plug into this DDS Secure capability. So you got different types of authentication. access control, lots of different types of cryptography. You can also tag data and say by classification level, and then filter on that as you move it through the system. You can also log events and log a lot of data if you want to actually do a replay of that in a simulation environment. Next slide, please. So like phase, this is a connectivity framework of standards. So we tend to underpin a lot of standards used in the industry. So if you heard of robotic operating system or ROS2 or ROS military, ROS-M, DDS is underneath that. So a lot of the connectivity that you see and a lot of ease and power of ROS2 is really based upon DDS. We also have got, once again, it's a face, and I'll talk about that in a few more slides. There's ground or generic vehicle architecture. This is a ground vehicle platform coming out of the European nations. All the next generation vehicles now are using GVA, and DDS underpins those capabilities. We're also, it can be used the transport side of open mission systems and lots of other platforms. So it's something that's naturally used as part of using other standards. Next slide, please. Now on a helicopter, here's a way of taking a look at the different types of data buses. You may have sensor buses for, let's say, the engines or rotor systems. Same thing for the tail rotor. You might have another type of data there. You then can put that data onto a flight control bus and then move data in and out of either the cockpit HMIs or the system, the mission systems in the back of the airplane. It doesn't make any difference. You can put in as many data buses as makes sense, but in a way you really want to be able to share as much data as possible in real time. Now, when I talk about sharing data, you're not actually going out in the pipe and trying to grab data. It actually shows up when you do a subscribe as local data in your application. So all of the application work that people typically do by trying to get data off a wire, you don't do. It just shows up as local memory, and it shows up in real time. Next slide, please. So interesting thing with DDS, we're actually also very strong in modeling, simulation, and training. There's a large show in Orlando every year, except for last year, called ITSEC. And that actually is a huge trade show for this industry. What we have done, and we're finding that the US Army and other military services don't want to have a canned demo from one vendor. They want to now mix capabilities between vendors. Not using a particular standard, but also taking the data from all these different platforms and then also mixing that with real-time data. So you actually can do simulations of missions using the data from the field of operations. This way the warfighter gets a sense for the cadence of data coming into their devices that they're going to support the mission. So it just adds a lot more, makes it a much more richer experience, and there also won't be a surprise when they actually land in a location and the data is not a nice fed data from a server. It's actually coming from the same source that they trained with. So they have a phrase, train as you fight. That's how you actually train as you fight. You actually use the data that you're going to be using in the operational context. Now, we did a joint demo 2 years ago at the ITSEC. We actually brought in a traditional simulation platform from VTMOC. Combined that data, that was an F-18 platform. We also combined that with a simulation environment, Unity, a gaming engine, and viewed that using a graphics platform called SimBlocks. Just for fun, we put some flight sticks up there. We put so we actually have flight simulator there, so we can actually control this aircraft if you want. We also then mix that on a live face platform, which had avionics hardware, and we had Harris flight scene being displayed on that platform. So it's a nice way to actually mix in a lot of different technologies without trying to rewrite the individual technologies themselves. And we'll see if you go to ITSEC this year, one of the big advances we're seeing is now gaming engines from both Unity and Epic Unreal, and we'll be showing off that this year. And you can do some really interesting things with gaming engines. You think about autonomy, how we're all going to view what's going on an autonomous platform. there's not going to be a person there being able to report back. You're going to have to see what's going on. So we're working on programs like simulating the Singapore airport, Changi Airport. Here's this massive airport. How do you know what's going on? So we're actually using Epic Unreal and using DDS to actually feed that data into that simulation platform. Okay, next slide, please. So how do we mix all this stuff together? So this is a bit of a challenge, but we can do this. So next slide, please. So one, we at Real-Time Innovations, we actually took our DDS product and pushed it through and created certification evidence for DO178C and EV12C at the DAL A level. So you can actually buy this COTS product that is all ready to go. There's over 5,000 hyperlink files, so you can very quickly look at this data. So if you do have a situation where you have to go through DO178C certification, we have a package of data ready to go for you. Next slide. We also, with FACE, were the first to actually create a FACE TSS using our DDS product. So we, and once again, we went through the conformance I talked about earlier in the slides. We're also going to use the, do it again with the latest FACE, what's called 3.1 TSS, and we'll do a conformance certification in Q2 of this year. And once again, we're going to create the DAL certification evidence. This will be unique in the industry late next year for this product. So you can actually now take a FACE TSS environment and put that into a certified platform. Next slide, please. Here's the interesting thing you can do with DDS, and we're finding this on the autonomous vehicle platform, where you're going to have in-vehicle compute requirements. And this is bringing in all the different sensor platforms for collision avoidance and navigation, and also trying to figure out what type of intelligence do you need to actually identify objects on the road and possibly objects that you really couldn't see as a human. These sensor platforms should be able to figure that out. You also are going to have a management layer above that. One is just a vehicle-to-vehicle communications. How do we actually talk to each other vehicles? Let's just say you have two vehicles approaching an intersection at 80 miles an hour. Do we actually have to stop or not? In most cases, if you have a good autonomous platform, you shouldn't have to stop. You should be able to gauge that timing to the point where you can actually just go full speed through an intersection. You're also going to have fleet management. You can't have all these autonomous vehicles running around without some oversight. So you're going to have a capability to actually control vehicles, especially if they stop working or they get into a situation they don't know how to go forward. You actually have this fleet management capabilities. And at the very top, you're going to have some type of analytics. You're going to have some type of cloud-based system that's going to be extracting data out of this operations. And that's probably the highest value area where you can actually get this data and then look at the data to try to figure out the best way to optimize both the operations, but also the experience for the user. Next slide. And by the way, this is exactly the same for UAM environments. The same things exist where essentially you have flight platforms, but you also have to figure out how do you manage these things? How do they communicate together? How do they communicate with the infrastructure? And then how do you take care of the entire operation? So another interesting side effect of FACE is that FACE has, as part of the standard, it does not require DO178C, any type of certification using DO178C, but as a side effect, people have actually done this. So like Real-Time Innovations, where we actually put together the certification evidence, other companies have done that too. So you see right here the list of FACE conformant suppliers. If you go to the next slide, almost all of those suppliers also now offer DO178C certification evidence. So this is a nice side effect where you can actually not only get a FACE stack and get very quickly to market, but now you can also have certification evidence to get you very quickly through certification. Next slide, please. So we have at Real-Time Innovation a lot of certification partners now. It's a very rich environment that work with us. And at the FACE TIM, we integrated over 20 different suppliers in the TIM. A FACE TIM is a technical interchange meeting where you actually get together all the FACE suppliers and put together different configurations. We did this in 2018, 19 and 20 didn't quite make it, so now we'll do this again in Huntsville on September 14th. We actually bring in all these different suppliers that have FACE products, but also have certification products. Next slide, please. So when you take a look at the solution stack, we talked about, I showed the stack for FACE. You can now put together very quickly avionics application, avionics solution stacks using this partner ecosystem. And whether you want to use FACE or not use FACE, this evidence tends to be almost the same, except for that transport services layer. So you can now build a very quick, rapid avionics platforms, and all you have to do is then focus on the top part, which is the avionics innovation. Next slide, please. Here's one of the platforms we just did in December with Boeing. This is the Boeing MSA Group, where essentially we got together with Boeing and the U.S. Army, Core AVI that makes certified graphics and GPU processors, certification evidence, Presages for HMI, and then RTI. So this is one of these FACE solution stacks where you can very quickly put this together. And then if a customer needs something of the same nature, they can actually use the components readily. Next slide, please. And the next slide will be with Bell. So we don't just work with Boeing, we also work with Bell and other providers. So here's just another FACE solution stack with Bell using different suppliers for the application. So there's test tool providers, there's operating systems, and other capabilities there. Next slide, please. So I mentioned before the Veron vehicle Skyscraper project. I think it's really important to understand that creating an eVTOL vehicle may be one of the easiest things to do. I think trying to secure that vehicle in flight and take care of all the politics and the technical challenges of integrating that into airspace that's right now really does not have a regulatory agency. The FAA does not manage things that fly above the street. Just educating people and how do you operate this? Who's going to operate it? Who's going to manage that? So just want to put that out there that I think tracking Veron vehicles, Skyscraper project is a really interesting one. So we also understand the context of building up an autonomous eVTOL aircraft. And next slide, and that should be it. I'm open for questions.
Thank you, Chip. Very much appreciated. That's very useful. We do already have a question in, and I'm going to get to that in a moment. Just first of all, since it's my job to answer the stupid questions, could you just clarify for me who is really behind FACE? You described that as a military standard, and you gave some good examples of companies who are engaged in that process. But who is ultimately behind that? Is that the U.S. Department of Defense or somebody else?
It's really Army, Navy, and Air Force are the prime services there. Obviously, special ops and other services can also use this technology. It's not limited. Interesting thing, the solutions that are created aren't really limited to any military prime or any military service. There's also all the major primes. So if you're doing military avionics in the United States, I don't care if you're Collins or Raytheon or BAE Systems, they're all members. And then there's a lot of other suppliers underneath that. There's about 100 entities now part of FACE. So between both the armed services and all the different suppliers. So it's a very, very rich ecosystem, lots of talent that goes into making that standard.
Yes, absolutely. No, that's a lot clearer. Thank you. I will get to the first question we've got from our audience, and I would encourage more to chime in. But while I've got your attention, you kind of teased us there, Chip, with a picture of that Vahana aircraft, which we've watched, and of course that was a technology demonstrator, very exciting early stage development in the eVTOL sector. But more broadly, from your experience, how engaged would you say the new eVTOL aircraft developers are in this standards process that you're describing for autonomous systems? Are they sort of completely tuned into this? And do you have any sense of the timeline that they're working to achieve autonomy?
So that's a really good question. I think that's just the crux of the issue is, autonomy, as I mentioned before, is not just the aircraft. So you have to have the environment around that aircraft, and that's the tough part. But yes, as eVTOL, any type of UAM platform goes forward, there's two different paths I see. There's ones that have taken, and I think you're going to interview them this afternoon, like Joby, that are essentially, I'm just going to do standard FAA processes. I'm going to have a pilot in the flying this thing. So I'm going to use standard FAA processes. There might be some autonomy there, but really the pilot's going to be in charge of everything. Just like, there's some autonomy in some type of flight control system, but really there's going to be a pilot there. The other ones are saying we're going to have a fully autonomous UAM platform. We may have a person on board that's more of a, not quite a pilot, because there's not going to be flying anything, but might be a concierge or something of that nature, just to make sure things go okay and people do the right thing as we sort of understand this new technology. And I think that's where we're seeing our growth. If you're just making a standard product, you might, using traditional technologies like manned technologies, you may use this, you may not, but as soon as you go autonomous, you need to bring in something that feeds all of that sensor and radar data into a common compute platform or a series of compute platforms that can make decisions in real time.
Right, and it's at that point that all of those standards you so well described are going to have to be met. And yeah,
so
okay, that's interesting. It sounds like that's a journey, and that's not necessarily the first step at all for the eVTOL sector.
Right, and FACE is not always required. It typically is on military programs, but if it's a commercial UAM, the FACE is not required. But the nice thing is, especially as the commercial industry has had some challenges with COVID, a lot of the development is compressed quite a bit. You can still there's still a rich ecosystem of people making DL178C software. It's just that it's now targeted toward FACE, because the military has now decided to move in that direction from using a military certification or airworthiness process to now requiring DL178C.
Very good indeed. Great. Well, we're going to jump into our audience questions, and the first one came from Kim Wasson. Kim is asking, Chip, can you please describe what your expectations are of DO178 and the other standards you've described as they apply to machine learning specifically? What's the connection between those two?
So they're tightly connected, and I really think, especially on the vehicle itself, but possibly the management of the vehicles also, you're going to have machine learning capabilities. Now, one of the interesting things that's just been announced is a company called Core ABI. They have created a Vulkan certification set that runs on top of GPUs and also the AI and ML engines on these GPUs. If you take a look, almost every major microprocessor manufacturer is now making an AI engine or some type of ML capability on these GPUs, which is a huge change from just a few years ago. So now, not only can you use that information, you can now actually do safety certification evidence around that information using this Vulkan and this Core ABI technology. And I think that's a huge step to getting us to the point where we can actually start integrating AI into the systems. That makes sense?
Very good. Yes, it does. Thank you. Thank you. I hope that helps. Another question here, this time from Vamsi Varigonda. Actually, two questions, perhaps related, I don't know. First of all, what do you think about the role of unmanned systems traffic management in eVTOL missions? You know, obviously there's a high degree of potential automation there. Do you have any views on that? And then I'll get to the second question.
I may have too many views, but I'll try to compress them down. So we have to figure out whether how we're going to manage this traffic. It's almost like, how do you manage traffic on the ground, but now you're going to have traffic in the air. So is that going to be private entities managing different UAM services, or is that going to be government controlled? We also have to figure out, does the FAA get involved with this? Right now, they're not funded to go do this, and this would be an extension of their current responsibilities, is to actually start managing UAM traffic down close to the ground. So they're really saying that's not our problem. And by the way, the U.S. Congress hadn't funded us to go address this problem. So we're not going to, take a look at it. You think about the Part 107, small UAVs. They essentially said it's not my problem until somebody funds us to make it our problem, which Congress did, and then they came out with the guidance, which I thought was very good. I think we have to understand that there has to be some type of flow of money to make all this happen, right? Unless we're going to just say only billionaires or trillionaires can actually run these UAMs, we have to figure out at a community level, city level, state level, who's going to manage this and how. And I think that's really key. So there's, once again, as I showed in that one diagram for autonomous automobiles, there's going to be layers of information that are going to be required to be exchanged between the different vehicles and the management of all the different vehicles, and also the infrastructure for scheduling the landing and takeoff of the, say, UAM platform. So I think that's really key. And I talked about a Veron vehicle, a Skyscraper. They actually have some nice graphics that actually show those tracks of the UAVs. And I actually have a video that I gave you folks. If you want to run that, if we have this time, we can run that video and actually show some of those tracks for UAMs.
Yes, I think we might have time for that in a moment. So let's see if we can do that. There was a follow-up question from Vamsi. Is there a centralized platform to handle all the standards out there, a sort of one-stop shop? I mean, I think you somewhat addressed that because you talked about a process where the standards can kind of be combined and integrated. But it sounds like there isn't just one house you can go to and check one box.
So I'm trying to do that at RTI. I'm not going to be the one house, but because we're right in the middle of the solution stack, we can actually have application suppliers like Harris and Collins and others supply applications. And also we have this rich ecosystem of board suppliers, of RTOS suppliers, doing both certification evidence for DO254 and DO178C. So to me, that's what I'm trying to contribute. And I've done this before with other partners. This because of our position at RTI, we're actually ideally suited to actually be that, entity that builds up this building block of all these different suppliers, saying, do you want this type of board or this type of board, like this OS or this OS? What applications do you want to run? Is it going to be face or not face? We can actually supply all of that.
Good. Okay, so that is going to streamline the sort of system selection process for a lot of these vehicle developers.
So it's just, before I would be at a trade show and we actually have a full solution stack, avionics box, RTOS, applications, everything else, graphics, touch screens, everything else. And I tell people, if you want this all exists today. It's already integrated using open standards, right? There's no lockdown. And if you don't like one of the components, we can put another component in here. Do you want me to put this on your desk tomorrow? Most people say, yes, please. I'd like to have that on my desk tomorrow. My boss will be very happy if I could actually have this working tomorrow versus 6 months from now trying to piece together all these different types of components.
Good. No, that makes sense. So for now, I've got one more question from our audience, and we certainly would welcome more. Maybe we might be able to arrange to see that video that you mentioned. But I've got a question here from Birol Akademir. Chip, did you include the environment into the hardware and the loop simulation? I guess that you mentioned before. I'm not totally sure what we mean by the environment there, but do you have any response to that?
So I'm not sure either what environment means. If you want to clarify, that'd be great. But I think what happens if we're talking about gaming engines, especially, you can create very realistic environments. And some of these training platforms also can do that same thing. They can create a very realistic environment for you to operate in. So a lot of these missions, if you think about doing a special ops mission, you could actually walk in or be dropped into an environment and have something that's very realistic to what you're going to be dropped into at some point.
Right.
So if that's the environment, that's that.
Yes, if that's what we mean by the environment, then that's how it is. Okay, good. Jim, I don't see any other questions at the moment, and to be honest, I'm pretty much at the end of my list of questions. Is there any chance we could look at that video that Chip referred to, perhaps while some other questions come in? I don't know how feasible that is.
Absolutely. I'll go ahead and load it up.
Urban air mobility is a revolutionary transportation development platform, capable of opening up new horizons for both technical and business innovation. Today, UAM can help vehicle manufacturers achieve the commercial deployment of autonomous air vehicles, opening up new markets and new possibilities. What's driving this autonomy? The world we live in. The blossoming of system infrastructure, sensor fusion, and 5G networks can now allow vehicle manufacturers to transcend earthbound barriers and use UAM systems to take autonomy to the skies. Consider the rise of the electric vertical takeoff and landing vehicles. For big cities, the solution to gridlock and infrastructure limitations may finally be here. These autonomous vehicles can freely traverse the skies, transporting products and people across busy urban landscapes. A clear case of science fiction turning into science fact. But with air vehicles, the stakes are higher. In fact, everything is elevated. The potential opportunity, the development process, the product lifecycle, and in turn, the race to get to market first. In this race, connectivity is everything. Where does this crucial connectivity come from? From RTI Connect's DDS. If your goal is a UAM system that can handle real-time sensor fusion, built-in flight control, and more, you'll need a proven software connectivity framework, one that can help you develop, certify, and launch an autonomous air vehicle. And that's exactly what Connect's DDS delivers. First, Connect's DDS tackles system integration by enabling the rapid insertion of new capabilities and pairing it with the ability to interoperate seamlessly with multiple UAM subsystem suppliers and legacy technology. Next, Connect's DDS enables system-wide control and security at all levels of operations to ensure fast, scalable, and reliable connectivity while protecting the integrity of operational data. Finally, Connect's DDS puts you on the path to achieving both airworthiness and the highest levels of safety certification, backed up by industry-leading airborne certification evidence. RTI has already helped numerous visionary manufacturers create unmanned air vehicles for the commercial market, so we know just how high the stakes really are, and how satisfying it is to witness a next-level design taking flight in the real world. If you want the competitive advantage offered by rapid time to market, Connect's DDS provides the software connectivity framework with the power to take you there. So plug in to the data-centric architecture your UAM system needs and leave your competitors far behind. Visit RTI.com and learn how we can help turn your UAM vision into reality.
Excellent. Thank you for sharing that. Just watching that, Chip, it's clear that that RTI is very keen to engage with these eVTOL developers. You possibly can't name names, but can you give us some idea of, are you already working with some of these companies? And if so, what sort of work are you doing with them?
Well, unfortunately, we can't do a press release yet. We are working with quite a few. I showed that one slide about how many autonomous platforms we are working with, and I mentioned that typically these are going to be companies that are going to go for the full autonomy mode. Many of those are still, I'll say, in stealth mode, or not really publicly talking too much about what their timelines are. But I expect some to be done here. At least some will be flying this year for sure, but not flying in production. Because once again, you need to have that infrastructure, and we have to figure out how that's all going to play here to do full autonomy on these platforms, just like you have to do with the cars. It's not like we have autonomous taxis flying around or riding around them.
Yeah, good. Okay, well, don't be shy. When you're ready for that press release, get it out to us, and we'll help you do some bragging, because that sounds quite exciting. Good. Okay. And in some cases, are you maybe not only going to be working with the actual aircraft developer, but perhaps with key system suppliers, such as the people providing the avionics suite and the flight controls and that sort of thing? Is that how you will engage too with these programs?
Typically, it'll be across the board. So there'll be people making a platform, but then there's going to be suppliers to that platform. So we work with them. There's also going to be people that are actually working on the control infrastructure that are outside the platform to platform and platform to infrastructure. So I think that's a really key use of our product there, because now you actually need to have this data exchanged, once again in real time to keep the separation and safety of flight. So it's exciting to watch this mature. It's fun to build an aircraft. It's really hard to build that aircraft that can actually fly through a city, an urban canyon. That's going to be the tough part. But as we figure this out over time, these platforms will come out and become reality.
Good. Okay, that's interesting. Now we've got another question here. I can't entirely see who this has come from, but the proposition and the question is this. This whole safety certification process still seems incredibly complicated and cumbersome. What are your recommendations for simplifying the process?
So one, go find a DER, FAA designated engineering representative of the United States or some other expert. Talk to them about what you want to go do, and then figure out how much of this can I actually get from COTS components. Because you don't want to, if you try to do this all yourself, you're not going to ever get done. You won't be done any type of reasonable time frame. So you can actually grab these commercial off-the-shelf certification components, software components, and use that. We also have got a SIBR, an Air Force, with this Air Force taking a look at what's called alternative methods. How do you actually certify applications faster? So this is still in the early stages. We're working with our partners on trying to figure out, is there another way we can actually do, especially do control software and mission software faster, where some of the artifacts come with it, so that the burden of test and certification is lowered. Now that's coming up. We'll have some results this year. We'll probably have some follow-on activity next year also on that.
Right, right. Very good indeed. Okay. Well, I am not seeing any other questions, and to be very honest, Chip, you've helped me a lot. I've probably increased my knowledge by at least 200 or 300% here, based on what you've shared. So I appreciate that. Unless there are some other questions coming right up, I'm going to be handing back to Jim Sherman in a moment. Anybody else there in the audience with another question? No? Excellent, Chip. Well, I do thank you for that presentation. That has been very useful. And with that, Jim, would you please pick up the reins from here?
I will sure try. Thank you so much, Charles, for a great job fostering through the questions. And Chip, great presentation, very, very detailed. I think you definitely helped our audience figure out a little bit about how this process all works. I guess I had one more question that I'd like to toss out there. A lot of times we see aircraft developers come on board with the design, and then they get through a certain amount of testing. They decide that they want to go get their certificate to fly. When should they start looking at DO 178 and 4754 and all those other great documents as part of their design? When should they start that process?
Well, I think you should start it with your design. There's actually design tools that will make that go easier. That are actually create some of those artifacts that are required. And I think that's the first part. So there's tools from MathWorks and ANSYS and others that can actually not only help you with the design, but also as you build out your design, you actually can have this carry-on certification artifacts that get delivered along with it. So I would actually start there, and I think most people don't do that. It's more fun just to get something to remotely fly, and then figure out, okay, so if we're going to go into production, we ought to just redesign everything. Let's just start from scratch and redesign everything, and using some of these tools. So it depends on how you want to get started. But if you're really serious about going through certification on that platform, or possibly just handing off that platform for someone else to manufacture and certify, you're in better condition, better shape if you actually say, and we did this in this context of certification. You don't have to reinvent this or essentially take our design, scrap it, and do it all yourself using the right design tools.
Very good. So your recommendation is start with this and then design the vehicle.
Yes. And I don't think it's ever too early to talk to a certification authority. They're going to help you They really want to help you do things correctly, so this burden is reduced. I haven't seen one yet that says, I want to guide people down the wrong path so I make more money. In most cases, they essentially say, I want to have this guy go to success, and I want to help them through the certification process, because it is onerous, but it doesn't have to be that onerous, and it is achievable, especially if you use COTS components.
Indeed, indeed. All right. I don't see that we had any other additional questions. So with that, I will go ahead and wrap up. So again, thanks to Chip and Charles for a great webinar. This will be posted up on our YouTube site, as well as Chip, if you give us permission, we'll post your presentation up there for people to access as well. It won't be on the YouTube site, it'll be on our webinar archive site. So we thank you for taking time out of your busy day, both of you. And with that, we'll close it down, and we'll catch you next time. So thanks again for everyone for joining.
Take care,
Thanks,
everybody.
Jim. Thanks, Charles.
Hey, thank you for joining, everyone.